Hello everyone, my name is Jiashu Zhao. I will teach you CP422 Big Data Programming in this term. Big data is a very popular topic in recent years, and of course with high demands. On the other hand, for university courses, especially undergrad courses, this is a new course. Before I joined L'Oreal as a tenure-track faculty, I have worked in the industry for several years. I really want to say, even though big data is a popular topic, there are not many experts in big data. One reason is that the education system usually has a lag in designing and promoting new courses. For most people working in the big data industry, they are not trained in big data when they are in the universities. So to some extent, we are lucky to get here, even though we are through online, to have this opportunity to study and practice the big data programming. For this course, we will teach asynchronously. There will be no scheduled classes. The course materials will be prepared and posted before the arranged meeting times. Also, we will have weekly office hours using Zoom. It's scheduled on Tuesday from 8 to 9 p.m. In this course, we are going to use some big data tools. Those tools can be installed on your personal computers, or you can choose to use the Amazon AWS service. The potential cost for the AWS server is less than $50 for this course. We do not have a required textbook, but there are many books in this field that are helpful to read as references. The evaluation is composed of 3 components. We will have 3 assignments, each worth 10%, midterm worth 30%, and the final is 40%. Now let's begin with today's material, introduction. Big data is a word that we talk about a lot. Everyone seems to know the word, even our grandmas. Let's formally take a look at these topics. What exactly is big data? Its characteristics, and why it's meaningful to us. Before we have big data techniques, we store and process data on a single computer. When the data sets get larger, we switch to a more powerful computer or server. However, the cost is usually quite high. With the explosive growth of data, one single server is often not feasible to store the data. What's more, the complexity of the algorithm to process the data often is an increment function of the input data size. The speed will be low when we use traditional approaches to deal with the data, or the large and complex data set that may not even fit in memory. So the definition for big data is, big data is a field that traces ways to analyze, systematically extract information from, or otherwise deal with data sets that are too large or complex to be dealt with by traditional data processing application software. Well, when we talk about big data, it's often referred to as the situation where parallel computing tools are needed to handle data. Big data does not only refer to the data itself, but also includes the challenges of capturing data from its sources. For example, video recording systems, or the user behaviors on the internet. Selecting data. Not all data collected are clean and useful. Processing data into a format for exhibition and easy to access. Storing large amount of data. Searching. Searching is to find useful and relevant information to serve for a given purpose. Sharing and transferring the data with other internal or external systems. Analyzing the data. for example, to find interesting knowledge or patterns, and visualizing the rich information in the big data. These are all the topics included in the big data challenges. There are many popular terms in the area. If we position big data around the other related areas, here is a Venn diagram for them. Data science, artificial intelligence, machine learning, neural networks, and deep learning, they all have overlaps with big data. For machine learning and deep learning models, they can be trained on a single machine where all the data are loaded into memory. Sometimes they are trained distributedly. Note that big data is not omnipotent. Not all algorithms can be trained distributedly. Let's get to know more about big data. The characteristics of big data, referred as 5 V's. The 3 of them are fundamental: volume, variety, and velocity. Sometimes we see 3 V's of big data, and then these 3 are components of 3 V's. Volume defines the huge amount of data that's produced each day. Variety refers to the diversity of data types and data sources for big data. Velocity refers to the speed with which the data is generated, analyzed, and processed. Later, 2 more crucial V's are added: veracity and value. Veracity is the authenticity and credibility of the data. How accurate and applicable is the data? Value denotes the added value of big data to business. To have a better understanding, we take a closer look at these 5 V's individually. First of all, volume of big data. We are in the age of data. We know that there are a large number of data in the world. But how much data exactly do we have? Well, we have a lot. In 2018, the global data sphere has 18 zettabytes. A zettabyte is 1 billion terabytes. This is the total of all data created, captured, or replicated. Not all of this data is being stored and kept, though, due to the limitation of technology capacity. Further, the amount of data grows exponentially, and by 2025, the world's data will have 175 zettabytes. This is a prediction. I personally believe this number could be higher by 2025 because we are generating more data and in the form of multimedia than before. We used to tweet a message, share a picture. Now we post and share more videos. These are much larger in size. Where are the data from? We are all generating data ourselves. Every interaction with our computer, our phone, creates data. Every interaction on social media creates data. Every time we walk down the street with a phone in our pocket, it's tracking our location through GPS sensors. That's more data. Every time we buy something with our contactless debit card, that's data. Every time we read an article online, our behavior is data. Every time we stream a song, movie, or podcast, that's more data, data, and data. The second V is the variety of big data. What kind of data are there? Variety of big data refers to the multiple data types that are gathered from multiple sources, including the relational data such as tables and transactions, the unstructured textual data from the web, the semi-structured data from for example, XML. The graph data where the items are linked to each other. The streaming data where we can only scan the data once, and the multimedia data, and so on. In the past, data could only be collected from spreadsheets and databases. Today, data comes in an array of forms such as emails, PDFs, photos, videos, audios, and so much more. Variety is one of the important characteristics of big data. In big data analysis, different types of data are often linked together to extract the desired knowledge. From the view of a customer, in this example, the data that are related to customer include multiple sources. The customer had some communications with friends on social networks, played some games, watched the movies and TV shows on some entertainment platforms, host some bank accounts, had some IBM and SAP services, and made purchases online at Amazon and in-store at Nordstrom. These data are collected and stored differently. All of them are showing different aspects of the same customer. But from the customer's perspective, all the behaviors are coherent and unified. Velocity indicates the speed of the data generation and the processing. How frequent or real-time is the data? First of all, the data is generated faster, such as Twitter and Facebook. Users are generating the data all the time, and the posts are available immediately. Another aspect of velocity is the processing speed. If the decisions are made late, opportunities will be missed. For example, if I go to a plaza, based on location and my purchase history, my interested promotions can be sent to me immediately. If the promotion sent to me late, for example, after 1 hour or 1 day, once I have left the area, the promotions will be less useful. Another example application is a healthcare monitoring system. It senses the patient's body and generates alerts when there is an immediate health problem. If the information is processed for a long time, then we are putting the patient at risk. So companies need information to flow quickly, as close to real-time as possible. Velocity is very important because it can give us a bigger competitive advantage. In terms of the speed of the data, now the data can be generated, censored, collected, measured by various sophisticated technologies. Recently, the innovation focuses on how to manage, analyze, summarize, visualize, and discover knowledge from the collected data. To timely and scalable treat the data requires big data related technologies. For a customer, from a company's point of view, there are multiple analytics and decision requirements at real time. Veracity indicates how accurate and applicable is the data. Data is often viewed as accurate, precise, and trusted. But the truth is that's not always the case. The data is always uncertain, imprecise, and difficult to trust. In the age of big data, where multiple sources of data will be analyzed together, there are more to consider, including the sources themselves, data types, and the processing of the data. For example, if the data is collected through IP addresses, then it's possible that there are multiple users from the same IP address, or the user is using VPN. Then the data is not as reliable as collected by usernames. The traditional data warehouse and business intelligence architecture tended to spend a large amount of time and effort on the data preparation. They try to reach high level of precision. Now, with the incorporation of unstructured data, which is uncertain and imprecise by its definition, as well as the increased variety and velocity, businesses cannot allocate enough resources to clean up the data properly. There are multiple sources of data veracity. Here are some examples. First, the data may suffer from statistical bias. That means the data we collected is different from the true underlying quantitative parameters. Second, lack of data linkage. An organization may get data from hundreds of sources, and one of the sources is inaccurate and lacks of the data linkage information to identify where the data has been stored in various databases. Bugs. A software bug causes data to be calculated or transformed incorrectly. Noise. For example, a self-driving car needs to decide whether a plastic bag being blown by the wind is a dangerous item or not. Anomalies. For example, there are two weather sensors located closely, but they report dramatically different conditions. Information security. An organization's data may be changed by advanced persistent threat. Untrustworthy data sources. For example, there are a large number of negative comments about something in social media. Sometimes it's not clear whether those negative comments are from a robotic source or they are from real customers being unhappy. Falsification. For example, a false rumor is spread by social media that a company is about to release some negative news. Uncertainty. So some statements released by some agencies may include ambiguous language, and the information behind the statement is not clear in that case. Duplication of data. When we duplicate the data may be corrupted in some way that cause the data quality issue. Out of date. An organization's database may be out of date, so that the business process may fail due to the out of date data. Human error. Our customer may enter their information incorrectly online. So all of this, and also there are additional sources that may cause the data veracity issues. And when we are working with big data, that's something we need to keep in mind, that the data is not perfect. The fifth V for big data is value. Although data is being produced in large volumes today, just collecting it is of no use. Instead, data from which business insights are garnered add value to the company. Once we have confirmed the viability of our key variables, we can then create a model that answers queries, delivers insights, and create learnings. While many companies have invested in establishing data aggregation and storage infrastructure in their organizations, they fail to understand that the aggregation of the data doesn't equal value addition. What you do with the collected data is what matters. With the help of advanced data analytics, useful insights can be derived from the collected data. These insights, in turn, are what added value to the decision-making process. The value characteristic is intuitively related to the veracity characteristic, that the higher the data fidelity, the more value it holds for the business. Value is also dependent on how long data processing takes. For example, a 20 minutes delayed stock quote has no value for making a trade compared to a quote that's 20 milliseconds old. Why do we learn big data technologies? There are more and more applications in the real world that requires big data handling. In our daily lives, we have many personalized requirements. For example, these questions, like there are so many articles, which news shall I read? And there are so many books in the world that's available online. How do I choose one? And I want to be updated about the new events, sports inventions, discoveries. So in those applications, the personalized recommendations are feasible through analyzing from big data. The patterns of the users are learned and then applied to us. For some problems, improvement of the algorithm often can be beaten simply by having more data and a less sophisticated algorithm. Those areas including data mining, machine learning, recommendation, finance. So recently, a friend of mine, she's working at Scotiabank. She complained to me about some packages provided by an external company, and I was like, why do you use their service? She's like, they have data we don't have. That's so valuable. Big data analytics has some unique characteristics. It is more real-time. It affects the decision-making management in more different ways than before. The traditional data warehousing architectures are no longer suitable for big data applications. Parallel computing is what we turn to as solutions for such use cases. This table shows the comparisons between traditional analytics and big data analytics. Big data analytics has a broader focus, can handle large-scale data, more types, and complex data. We aim to find more insights and accurate answers using big data approaches and the vast amount of more data. That is all for today. Hope you have some understanding about big data and how big data is different from traditional approaches. That is related to the way that we program with big data tools.